Hi and welcome to this week's video. Today I want to show you the insertion sort. Last time, as you remember, we had a look at the bubble sort, and this time we talk about the insertion sort. In the insertion sort, you are comparing two elements and sorting them, and then you're looking at the third element and then you insert it into the right position. So let's don't talk too much and jump right in, and I can explain you more about that. So I created a new file called insertionsort.py, and here I inserted the same array as we used in the bubble sort. And so let's explain how the insertion sort works. So in the first iteration, we again look at the first two elements like in the bubble sort, but this time we are not swapping element by element. We are just looking at those two elements and compare them. So we are looking here at the 5 and the 2, and then we are realizing the 2 is actually smaller than the 5, so we are inserting the 5 in the first position, add the 2 in the first position, and the 5 in the second position. And then we are looking at the number 6, the third element, and actually here nothing changes. Same with the 8, nothing changes, but then here at the 3. So the 3 is actually smaller than the 8 and the 6 and the 5. So if we look at the 3, we are inserting it here into after the 2. Same with the 1. The 1 pushes all the entries one index behind, and same with the 0. So I guess you get the idea. We basically just push all the numbers which are larger than the current looked number to one index to the right in the array. So the 9 goes here, stays there, and the 7 pushes the 8 and the 9 again, one index to the right. Yeah, and then you have a sorted array. So, but how does that look in code? So if we want to code that, so all we need to do is to define a for loop. So for each number in the range of our array, so we could go with the length of the array here, but I just go with 10. So we are doing this 10 times. And in here we are defining the current element, which is our number minus 1. So array starts always with a 0. So we also have to get the index 0. And then we are getting our next element. And this one we are getting our array, and from our array we are getting the number. I just rephrased that maybe to index. This is our index of the array. Okay, and then we are simply defining a while loop. So we need to look at our array into our current position and compare that if this is bigger than our next element, and if the current element is also larger or equals to 0. And while this is true, we take our array entry current plus 1 and set that equals to our array current. So if we look at the number 5, we are taking the number 2 and write number 2 into the position of the 5. And then we are setting our current to the current minus 1. That's it. At the end, we are going to the array into the current plus 1 index and set that equals to the next element we want to look at. And this is everything you have to do here. So now we can actually print our array at the end and execute our code. And as you can see, we have a sorted array from 0 to 9. Yeah, that's actually how easy the insertion sort functions. As you can see, the algorithm isn't that hard to implement. That's also one benefit of the algorithm. The strength of that algorithm is if you have arrays which are nearly sorted, the algorithm is easy to implement and is also fast then to sort those arrays. As well as if you have small arrays like we had, like with 10 entries, the insertion sort is actually very performant. If you have large arrays which are really all over the place and unsorted, then the insertion sort isn't that good and doesn't perform well here. So next time we are taking a look at another sorting algorithm with Python. And of course, you can apply the insertion sort algorithm I showed in all the languages you know of. Yeah, so I hope you liked that video and don't forget to subscribe to my channel. See you in the next one.